everyone, it's CubeChamp, and today I'm going to be teaching you how to solve the Square-1. The Square-1 is one of the most interesting WCA puzzles, as it is the only one that can shapeshift. If you take a normal 3x3 and turn it, it stays in its cubic shape for the entirety of the solve. If you take a Square-1 and turn it, as you can see, it does not stay in a cube shape and becomes very jumbled and disoriented, which can stray away a lot of beginners. For this reason, it can stray away a lot of beginners, but it is really not as hard as you might think. You could split the steps of solving a Square-1 into 3 main steps: cube shape, orientation, and permutation. The first step is cube shape. This step is to put the Square-1 back into a cube shape, and it will look something like this. The next step is orientation. The main goal of this step is to have all the whites on top and have all the black or yellows on the other side, like that. The final step is permutation, where the goal is to solve the rest of the cube, like that. Square-1 notation is a lot different than what you would see on your normal 3x3. Instead of using R and U moves like on a normal 3x3, it uses numbers and slashes. Each slash refers to an R2 of the slice layer, so all a slash is moving it like this. To differentiate the value of the rest of the moves, we give each corner the value of 2 and each edge piece the value of 1, which you can kind of see as the corner is about twice the size of each edge. So, for example, a 1 would just be like this, since an edge is only worth 1, but a 2 could look like this, since a corner is worth 2. So your basic U move would be a 3, like this, because you are moving 1 edge and 1 corner, which is 1 and 2, for a total of 3. The same thing is true for your opposites, so a negative move would go the other way. It's kind of like a U prime. So a negative 3 would move like this. Positive 3, negative 3. The same thing is true for the bottom layer, except for this direction it is positive and this direction is negative. So 3, negative 3, negative 1, 1, 2, negative 1. You can even go more than 3 on this cube. So, for example, a 4 would look like this, and then you would do a slash, because it was going 1, 2, 3, 4. And then a negative 4 would go negative 1, negative 2, 3, negative 4. You could do the same thing for the bottom. If, for example, if we want to do a 5, I can go 1, 2, 3, 4, 5. And negative 5, I can go negative 1, 2, negative 3, negative 4, 5. One of the easiest to remember is 6, because it is always just a double move. So 1, 2, 3, 4, 5, 6. And you could do it in either direction, so it will always be written as positive, because you could do a 6 like this, and a 6 like this, and it doesn't matter, it's the same way. And it also goes the same way on the bottom, so 6, and also 6. One quick note, when you're doing algorithms, you want to have this longer piece always in front of you, so that way when you turn it, you have 2 littles in front, and in the back, you have 2 bigs. You never want to turn with a little piece in front, because you're going to turn it and get 2 bigs, and the algorithms won't work if you do it this way. You should always make sure that you're doing them this way, where you have the 1 long, and then when you slice, you have 2 littles. Let's go try out an algorithm written in Square-1 notation so you can see this in an example. 1, 2, slash, 3, negative 3, slash, 3, 0, slash. That is an algorithm. It doesn't really do anything, but just to show you an example. So the first step in solving the Square-1 is to get it into cube shape. And to show you this, I want to take you on a little journey, and we're going to go from cube shape to something else. And I want to show you how that works. So as you can see, if I go ahead and do a slice, we get these 2 shapes on the top and bottom, which are considered kite, because it looks like a kite, and it's on both sides. So then if we go ahead and turn these two layers in opposite degrees and do another slash, we get these little groups of 2s on all the edges. This is called barrel barrel. Now if we go ahead and align the edges like this and like this, that way when I slice this up, it's going to pair right here next to it, like that. And when I slice that up, it's going to come next to it over here, like that. So if we go ahead and do this, you're going to get this shape, which is called scallop scallop. If you take scallop scallop and go like this, you're going to get this shape, where you have all 8 edges on top, and you have no edges on bottom, only corners. And this is the shape you want to shoot for when you're solving cube shape. That way when you do this, you could do it in the opposite order. So if we go ahead and take it from this shape and go to cube shape, we're going to do the exact same thing, but in reverse order. So the first thing we want to do is go ahead and do a slash and get this scallop scallop. What you want to do with these is set all these 4 edges, put them at the front. Once you have them in the front, you can slice down the middle. Then you want to take the bottom and put the 2 corners that are together, put them in front, and then on the top you want to slice in the middle of 2 edges that are together. So if you go ahead and slice like that, then you're going to go back to kite kite, put the 2 corners that are touching in front, and then slice, and you're going to have cube shape. If you do better with solving as an algorithm, I'll go ahead and show you an algorithm for that too. And it goes slash, -2, -4, slash, -1, -2, slash, -3, -3, slash. You can use either of these methods to solve it, whether it's an algorithm or just knowing how it works. Either way works, whatever feels more comfortable to you. You might be asking yourself right now, how do I take my completely jumbled cube and turn it into this shape with 8 edges and all corners on the bottom? So this is kind of where trial and error takes a big part of this, but I'm going to show you some shortcuts and tricks that could really help with this. The first thing I want you to notice is if we take the shape and move it like this, you can see that we're going to have 6 edges here and a line of 2 like this that we can move. If we go ahead and put this at the bottom, you could see that if we have 6 and 1 line, no matter what shape it in, maybe it's like that, as long as we put the line like this, we can put it right into here and still get the 8. This can be helpful because a lot of times when I was first solving the Square-1, it always frustrated me when I get a shape like this, which is scallop kite. A way you can do this very, very easily is by taking your little lines and go ahead and put it up like that. What you could do with this is take your 2 here and pair it up with these 4, kicking out this line, knowing that if we have 6 in a row, we could just put the line back in. So if I go ahead and take these 2 edges and put it up with this 6, then we have 6 here, then we can go ahead and put our line in there, so we already have 8. Another way you can use the line method is if you have a shape like this. This is also a struggle for me when I first started pairing edges, because I'd be like, oh, I have 4 up here and 2 down here, but I don't know how to get this. And there's a very simple fix to it. All you have to do is move this little L up to your row of edges. And as you can see, we get the same shape as we do before, where we can simply take our 2, go ahead and replace the L to make 6, and put the L into place. I'm going to go ahead and show you some examples of some jumbled up cube shapes going into cube shape. So what we could do here is, my first thing that I see is that we have a bunch of stray ones down here that aren't connected. And what I'm going to do is I'm going to go ahead and move this little L down here onto this L, which is going to give us an edge and a line like this. And we can use both of these to our advantage. So what I'll do first is I'm going to go ahead and put the line up with these 2 in here. Then I'm going to take the L and replace it. And what I can do from here is I can go ahead and take this line of pieces and I'm going to put it up here so we get all even edges. So what I mean by this is I have 4, 2, 2, and 2. If all your edges are even, you can easily put it into the shape of 8, because all you have to do is pair them into 4 and 4, like this. And then you could put the 4 and 4 together to get your 8. I'll go ahead and just show a few more examples of cube shape here. So we have this one that looks very, very funky. What I'm going to do here is I'm going to take this little L and I'm going to pair it with this, because it's going to make 2 together up here. It'll look something like this. So if I do that, it's going to make 2. And what I can do from here is if I go ahead and move these 2 over so I can put it up here, I'm going to get the same shape of 4, an L, and then 2 on the bottom as we've had before. So we go ahead and put that up. I have 4 and my L, 2 at the bottom, and you know what to do. Go ahead and move your edges up, make your 6, and put your line in to get your 8. Go ahead and show you one last example here. As you can see, this one doesn't look fun because I only have one group of 2 and the rest of the edges are separate, but we can actually do this quite easily. So I'm going to go ahead, take this L here, pair it with this L to go ahead and get me a pair of edges and a line. From here, I'm going to go ahead and put the line down here with these. That gives me a 3. Then I'm going to do something like this. Put my L with that, because from here I can go ahead and put my line with these to give me a group of 4 and a 2. So like that. And I can go ahead, put that one in where it goes. And I'm going to go ahead, set this one here, and I'm going to move these all up to the top. So that just shows you that you can also build them on the bottom and it works just as well. I do know that cube shape can be quite frustrating. It was one of the hardest parts for me to understand when I first started learning the Square-1. So if you have any questions or if you're stuck on a specific case, let me know down in the comments and I can answer it. So once you have your puzzle back to cube shape, the next step is to make all the tops white and all the bottoms either yellow or black. My cube has black, your cube might have yellow. All works the same way. The first step you want to do is you want to go ahead and orient the corners. This is probably the easiest step on all of the Square-1. One thing to note, if I align the layer by one piece and then do a slash move, it will stay in the cube shape. So you need to use this while you're orienting the corners. The way you do this is basically the same way you make the centers on the 4x4 if you've ever done that. So what you want to go ahead and do is make an L first. So I have 2 white corners on the bottom, and I'm going to bring them up here next to this one. So all I have to do is offset it by 1 and bring it up. Now I have an L. And then on the bottom I just have 1. Next thing you want to do is always make sure your bottom 1 corner is in this spot. If it is in this spot, then all you have to do on the top is move it to here, and then go ahead and make sure you still have this offset by 1. Go ahead and do a slash, and then move it over. Make sure it's still offset by 1, where you have 2 here, 2 here. Then you can slash again, and you'll have all the top ones solved. This is the easiest part of the Square-1. The next step is called edge orientation, where the goal is to get all the edges on the top and the bottom the same color. There are a variety of different cases you might get, but you only have to learn 2 algorithms to do all of it. The first algorithm is for when you have 2 lines on the top and bottom, and it goes like this. 1, 0, slash, -1, -1, slash, 0, 1. And that will solve that. The next case is when you have edges next to each other on the top and bottom. You want to hold the edges in the front and the right, and the algorithm goes like this. Slash, 3, 0. Slash, -3, -3, slash, 0, 3, slash. And you see that gets us right back into our line case that we could solve with the algorithm we learned earlier. The next case is when you have a line on one side and 2 edges next to each other on the other. You want to align it so the edges are in the front and back, and then here you want them to be in the front and the left. Then you want to do the algorithm we did earlier. That goes slash, 3, 0, slash, -3, -3, slash 0, 3, slash. And as you will see, it will bring us right back into this case where we could set it like this. Do this algorithm again. And then do this algorithm. The next case is when you have just one singular edge on each side. What you want to do is put this edge in the front and this edge on the left, and you want to do the very first algorithm that I showed you. So it goes like this, and that'll lead you right back into this one that we did earlier. The next case is when you have 3 edges not solved on both sides. So for the top, you want to put them in the front and the left and right. And then on this side, you want to put it on the front and back and then the left. And you want to do the first algorithm I showed you. And it will lead you right back into this case, which we have already done. So the final case is when we have no edges solved on either side, but this is actually quite easy because if you take a closer look, you can see we basically just have 2 lines on every side. So you could do the first algorithm I showed you, and then all you have left is 2 lines, which you want to set like this, and then do the algorithm, and you'll be done. The next step is called corner permutation, where the goal is to get all the corners in the correct spot where they need to go. There's a lot of different cases you can get for this. The first case we're going to cover is when they are both adjacent, so they need to swap like this. As you can see, these 2 are already good. And then on the bottom, they're going to need to swap these 2 across from each other. What we could do here is we could set the good ones in the front, so like this and like this. And we could do the same algorithm I showed you earlier when you have these 2 and these 2 edges not solved, which goes like this. And now all of your corners are good. The next case I'm going to show you is when you have one of them adjacent, just like this, and the other side is diagonal. You want to put the adjacent side on top, so you can go ahead and flip it over if yours is on the wrong side. This is going to be a new algorithm, but we're going to use this for the rest of corner permutation and for the rest of the solve. And it goes like this. Slash 0, -3, slash 0, 3, slash 0, -3, slash 0, 3, slash. And as you will see now, the top and the bottoms are both good. We can use this algorithm now when the bottom is good and the top is adjacent, but we have to be careful because if we would do this normally, it's going to mess up the bottom. So what we have to do first is put the 2 solved pieces into the back and then go ahead and do our algorithm. As you can see now, it messes up the bottom, which is okay because we can fix it. So now we just need to set these 2 to the side like we did earlier. And now we have the adjacent and diagonal case again, which we could do with the same algorithm. Like this. The last case is when the bottom is good and the top needs to swap diagonally. We could do this the same way by doing the same algorithm we've been using. And then it messes up the bottom. Go ahead and put your side that is solved to the left and do it again. And now your top and bottoms are going to be good. If you only have 3 pieces left to switch, like I do here on top, it's going to be really easy, and all you have to do is use the same algorithm we used earlier. So what you want to do is you want to look on the piece on the right and see where it needs to go. So for example, my piece here needs to go in the back. And what you want to do is you want to offset it so it can stay with the layer. So you see if I turn this, this red edge is going to stay with the red piece back there where it needs to go. If this needed to go up in front here, I wouldn't offset it because as you can see they stay in the same layer and this one doesn't. So what we're going to do here is offset it, and we're going to do the same algorithm we've been doing before. And then we're going to go ahead and reset it back to normal. And then our top is going to be solved. If this edge needs to go on the front like this, we're going to not offset it so it stays in the layer with this, and do our algorithm. And then we're going to go ahead and offset it now, and then do the algorithm. And our top will still be solved. Another case you might have that means you don't have parity is when they need to switch opposite of each other. So these two need to switch like this, and these two need to switch like this. What you could do here is the same thing we did before. So go ahead and do your 3, and then offset it, and then do that algorithm again. And you'll see we're going to have this 3 case again that we can go ahead and solve. The last case you're going to have is when they're adjacent and they need to swap like this and this. You can go ahead and do the same thing, do our algorithm, offset it, and then do our algorithm again. And as you see, we'll get back to this 3 algorithm. If you have any other case, that means that you have parity. And what you want to do for this is go ahead and find a piece that you could put on this side that you could solve like we did before. So this blue one, and go ahead and offset it, and it would go back here. So we could do our algorithm, and go ahead and offset it, and do it again, and then we'll be left with just 2 pieces to solve. Once you've solved the top now, what you want to do is solve the bottom, but you don't want to simply flip this over because as you see we have the little side on front, and we know we don't want that. So what you're going to have to do is do a slice move, and then move both the top and the bottom layers 180 degrees, and then slice it again. That way you get the long piece like this. The final step that you might get on Square-1 is called parity, and it is when just these two need to switch like this, and everything else is solved. You might have a case that looks like this, where it's swapped from across each other, and all you want to do is do what we did before, and do your algorithm, offset it by 1, and then do the algorithm again, and you're going to go ahead and get this parity case. And this is one of the longest and hardest algorithms you'll have to learn, but stick with me because after I do this, I'm going to show you some tips on how to memorize it and really break it down. So the Square-1 parity algorithm goes like this. /-3 0 /0 3 /0 -3 /0 3 /2 0 /0 2 /-2 0 /4 0 /0 -2 /0 2 /-1 4 /0 -3 and you are done with parity. So on the Square-1 parity algorithm, it's really going to help if you break this up into groups. So the first group I want to separate is the group of all 3s, so the first 4 little things you see. So it goes /-3 0, and then you know to slash again, you go /3 /0 -3 /0 3. So if I go ahead and undo this, you can go ahead and see that the first move is going to be on the top layer, and the next 3 are all on the bottom. So you know it's /-3, and then if you slash go this way, slash go this way, and then slash go this way, then you've already learned that portion of the algorithm. The next part I want to put into groups are these next 3 2s. So it's going to be /2, 0, /0, 2 /-2 0 So you can know that because you know you're moving always 2, and it's always just going to be moving 1 corner piece. The next thing I want to break down are the next 3 groups of moves. So the first thing you're going to want to do is a 4, because as you can see, you're going to get these 2 edges next to this 1 edge, and this is really what you need to pay attention to during this step. So it's a slash, and then all you want to think about in this is that you're simply moving these pieces to be sliced here and then back to here. So you're going to move it like this, and that's going to be your 0, -2. Then you're going to slice, and you want to simply just move it back and then slice. And that's a really easy way to memorize that step. The next thing you want to think about is where these corners go, because you have the same shape on both the top and the bottom, so you just really want to know how they're aligned. You want to move these two on the side like this. That way this piece lines up with the little piece here. And then you want to put these two corners that are together in the back. That way you have all the same color here. And that's just a really easy way to think about it. And then you can go ahead and slice. And then we have the same kite shape from before. Then you can go ahead and just move these over and slice. My final tip for you is that if you can tell that you have parity on both sides like this, whatever you do, do not do the parity algorithm twice. All you need to do is one very short, simple algorithm that we have already learned. So it's going to be the same algorithm as when we have this case, where we have one line and one line, plus a little extra. So what we do is the same algorithm as before. And then all we want to do is a U2 or a 6 move. So like that. And then if we do it again, you could see that on both sides we will not have parity. Yay, you did it! But maybe not. There might be two different cases that you have left. The first one is when you have this piece called the equator that is flipped. All you want to do for this is slice, move the top 180 degrees, slice 180 degrees, slice 180 degrees, and then you're good. The next thing you might have is solved besides these two little pieces. And you could do the same algorithm I showed you earlier, where all you do is slice, move the top and bottom 180 degrees, and then slice. And yay, you did it! Congrats on solving the Square-1. I'm going to go ahead and leave some helpful tips down in the description for you, along with algorithms that you might need. Thanks for watching. See you soon.